In this session, we are diving into one of the most powerful and flexible concepts in C programming, function pointers. We will break down function pointers step by step, explore real-world applications, and see why they are so important for advanced programming. So, if you are ready to level up your C programming skills, stick around. This is going to be very interesting. Before we dive into function pointer code, let's first understand its benefits and practical scenarios where function pointers are commonly used. Function pointers let you store and call functions dynamically, making your code more modular and reusable. They are the secret sauce behind event driven programming, callbacks, and even building custom libraries. Here are some of the practical scenarios where function pointers are commonly used. Thread management. Function pointers allow dynamic assignment of thread entry points, enabling parallel execution of different tasks efficiently in multi-threaded programs. In operating system, function pointers interface with drivers, system calls, and interrupts, ensuring scalability and flexibility for dynamic system management. In case of dynamic libraries, they enable runtime linking and execution of functions from shared libraries, making software modular and adaptable to changing needs. In event-driven programming, function pointers enable callbacks, allowing user interfaces to dynamically handle events such as button clicks or timer triggers. And in embedded system, they manage hardware interrupts and task scheduling efficiently. Function pointers empower dynamic behavior in software and can transform your programming approach. So let's learn. Now let's understand basics of function pointers. Each function in a program is stored at a specific memory address in the code segment of the memory. So what exactly is a function pointer? A function pointer is a variable that stores the memory address of a function. Just like integer pointer stores the address of an integer variable, function pointer stores the address of function. Let's write one simple program to demonstrate the use of function pointer. Let's write one add function. Int add, it accepts two numbers, int a and int b, and it returns the addition. Run a plus b. Let's write one simple main function. Int main. Once we compile this code, memory is reserved for each of these functions. So let's say in the code segment, add function starts from 1000 address. Now how do we declare a function pointer and use it? To declare a function pointer to add function, we can write statement like this. Int, it should accept two arguments, int comma int, and here the name of the pointer star, say fptr. Here important point to note is the return type and input arguments should match with the function. So here add function accepts two integer arguments. So we have two ints here and it returns the integer variable. So we have int here. This statement tells compiler that fptr is a function pointer which is pointing to a function containing two arguments and returning one argument. So the return type and function arguments should match. Now how do we get the address of this add function and assign it to fptr? We can write statement like this, fptr equal to add. In C, the name of the function automatically decays into a pointer to the function. Therefore, writing the function name is equivalent to its address. How can we call add function using function pointer now? Let's declare one more variable int c and call the function fptr of say 2 comma 3. Let's pass two arguments. If we run this program, this statement will call the add function and it will return the answer 5, which is the addition of 2 plus 3. Now let's code it to see the function pointer in action. Let's understand function pointer with the help of this code. Here I have defined two functions. First one is add function, which returns the addition of two numbers, and the second one is the square function, which returns the square of a number. Here add takes two arguments and square takes one argument. Now how do we declare function pointers for these two functions? The signature of function pointer should match with the function arguments and return type. That's why we have int fptr of a and two integer as arguments. So this function pointer can point to add function. Similarly, for square function, we have one int as return type and int as argument type, and the signature matches with the square function. Hence, this fptr of s can point to a square function. So here fptr of a equals to add, which means add function address is assigned to fptr of a, and using this statement we call the function add fptr of a 2 comma 3, so it should return value 5. Similarly, square function pointer is assigned to fptr of s, and then we are calling the square function using fptr of s and 5 as argument. So the output should be 25. Let's compile this program and run. Now let's run the program. Here, as you can see, addition is 5 and square is 25, and both add and square functions are called through function pointers. In the next segment, we will discuss more advanced function pointer concepts.